In this video, you're going to learn how to classify matter, how to separate mixtures, and how to read a solubility curve. Matter, which makes up almost everything, is classified into 4 major groups. They're elements, compounds, homogeneous mixtures, and heterogeneous mixtures. And each of these has their own properties. Elements are the simplest form of matter. Compounds, which are also pure substances, are made up of elements but are chemically combined. The elements are connected together. And we also have mixtures, which are a combination of elements or compounds that are not chemically combined. And we can group those as these are either homogeneous or heterogeneous. So elements are the simplest. Compounds are made up of elements. They can be broken down into elements chemically. And then we have heterogeneous mixtures, in which there's stuff mixed together but you can see the pieces in it. And then there's homogeneous mixtures, the same throughout, and these are also called solutions. Here are some examples of these 4 types of matter. Gold is an element, and if we take any piece of this gold, it's going to be the same kind of atom. It's all gold. This is a compound, and this compound, also called baking soda, is made up of sodium, hydrogen, carbon, and oxygen. And these are chemically combined. We can't separate them unless we have some kind of chemical reaction take place. In this chocolate chip ice cream, we can see the pieces in it. So this is a mixture of the ice cream with the chocolate chips. That is a heterogeneous mixture. And we can think about this as being able to separate it out. Even with our fingers, we can pluck out the chocolate chips. Whereas in an iced tea, we have a solution, right? The tea, and if you have sugar in there, is dissolved into that solution and it's not going to come out. And we can't see the pieces of the tea or of the sugar that's dissolved in it, right? That's a solution. We have water on the left and salt on the right. And if we take the salt and put it into the water, we can make a salt water solution. The water is the solvent and the salt is the solute. And notice once you stir it, you can't see the pieces. It's dissolved. This makes it a solution, a homogeneous solution. This stew is an example of a heterogeneous mixture. You can see the pieces. That way you know it is a heterogeneous mixture. And we can take these mixtures, either the heterogeneous or homogeneous mixtures, and we can separate them. And mixtures are separated using physical properties. Filtration, we can separate them by size. If we have a filter, we can let smaller pieces through, larger pieces are left behind. Evaporation, if we have a liquid and there's a solid dissolved in it, or there's just a suspension and there's some solids floating around in there, we can actually boil off whatever that liquid is and leave behind whatever the solid is. In magnetic attraction, if it's cobalt, nickel, or iron, we can use a magnet to take it out of the mixture. And with distillation, we can separate 2 liquids by heating them, and one will turn into a gas and one will probably stay behind. So this is similar to evaporation, but with distillation, we have 2 liquids. So here are pictures of those 4 ways to separate mixtures. Filtration, we have a funnel, we put filter paper in it, and whatever the bigger stuff is left behind, the smaller stuff goes through. In evaporation, the liquid evaporates or boils off, and we're left with whatever solid stuff is behind. Magnetic attraction, we use a magnet to take out whatever is attracted to the magnet, probably iron, nickel, or cobalt. And in distillation, you can separate 2 liquids using an apparatus like this. How do you read a solubility curve? Now, you read a solubility curve as you would any graph. But we need to look at these axes first. For this, we have temperature on the bottom axis in degrees Celsius. On the side, we have grams of solute dissolved in 100 milliliters of water. So here we have a solute that's dissolved. Here we have a temperature that is increasing. So the higher the temperature in this case, the greater the amount of solute that's dissolved in 100 milliliters of water. And like anything else, if we're looking for how much is dissolved at 20 degrees Celsius, we go to 20 degrees Celsius, we go up to the line we're looking at, and we go across, we can see what number it meets up with. In this case, it meets up with 200 grams. At what temperature will 300 grams of sugar dissolve? To look at this, we go up on this side first, across, and then down. In this case, we can see that it's 64 degrees Celsius. So you just have to go from either axis and meet up with the line that it's talking about. Now this line shows the saturation curve. So at this point, if we're trying to dissolve like sugar or salt into a container of water, at this point, at this temperature, no more will dissolve. It's called saturated.